Today we're going to talk about the chain rule. So this is a very important rule that is going to be very powerful for you to find derivatives of composite functions. So a composite function, remember, is something that looks like this: f of g of x. You've got a function inside another function. Okay, so here's the definition of the chain rule. If y is f of u is a differentiable function of u, and u is g of x, is a differentiable function of x, then y equals f of g of x is a differentiable function of x, and the following is true. The derivative of y with respect to x is the derivative of y with respect to u times the derivative of u with respect to x. Okay? That's confusing for most people to follow. I think this is a little bit easier. The derivative of f of g of x is simply f prime of x, the derivative of f of g, the derivative of f of g of x times the derivative of g of x. So you take the derivative of the outside function and then you multiply that times the derivative of the inside function. Okay, you need to know the chain rule for the AP test. So they decompose some composite functions here. Y equals f of g of x, u is the g of x, and so y is just f of u. So you just put that inside there. Here's a couple of examples. Y equals 1 over x plus 1. So they make u x plus 1, and then this simplifies to y equals 1 over u. Y equals the sine of 2x. Let u equal 2x, and then y is the sine of u. Let y equal the square root of 3x squared minus x plus 1. Let u equal 3x squared minus x plus 1, and then y is just the square root of u. And finally, y is tangent squared of x. Let u equal tangent of x, and then y is u squared. Okay, so use the chain rule to find the derivative of y equals x squared plus 1 to the third power. Okay, so y prime is going to equal, we're going to take the derivative of this whole thing. So I'm going to use the power rule. 3 comes down here. 3 times 1 is 3 times x squared plus 1. Drop the power 1. It's now a 2. Now I've got to use the chain rule. I'm going to take the inside of this, x squared plus 1. I'm going to take the derivative of that. That's going to be 2x. And I'm going to simplify this, combine what I can. So this is going to be 2x times 3 is 6x times x squared plus 1 squared. That's probably as far as I would go. You could multiply this out if you wanted to, but I wouldn't recommend it. So the general power rule, if y is u of x to the n power, where u is a differentiable function of x and n is a rational number, then the derivative of y with respect to x is just the power rule. So you take the exponent, multiply it times the coefficient here of u of x, drop the power 1, and then you take the derivative of the inside of this thing. Might be easier to understand it this way. The derivative of u to the n power is n times u to the n minus 1 power times the derivative of u. So let's find the derivative of f of x equals 3x minus 2x squared to the third power. So f prime of x, 3 times 1 is 3, times 3x minus 2x squared, drop the power 1. Now I've got to take the derivative of the inside. That's going to be 3 minus 4x. You might simplify that a little bit, or you can just leave it just like this. Here's the thing on the AP test. If they're testing you on the chain rule, and I've done the chain rule correctly here, and then I go and I try to simplify this to get a better answer or to get a nicer looking answer, and I make a mistake, then I get the question wrong. Okay. Okay. Find all points of the graph f of x equals the cube root of x squared minus 1 squared, for which f prime of x is 0, and those for which f prime of x does not exist. Okay, the first thing I would do is I would rewrite this. I would rewrite this as f of x equals x squared minus 1 to the 2/3 power. Okay, remember, this tells you that that'd be the 1/3 power, and this is squared, so that'd be the 2/3 power. Okay, now I can take the derivative of this thing pretty easily. Okay, 2/3 times x squared minus 1, drop the power 1, so that's going to be the negative 1/3. Now I've got to multiply that by the inside, the derivative of the inside, so that's going to be 2x. And I would combine this here. F prime of x is going to be it's going to be 4x on top. It's going to have a 3 in the denominator, and this is the cube root in the denominator, so cube root of x squared minus 1. Okay. Now, we were supposed to find when is f prime of x equal to 0. Well, it's equal to 0 when the numerator is equal to 0. So when is the numerator equal to 0? 4x equals 0 means that x is 0. Okay? So that means that this thing is, when x is 0, then I get f prime is 0. So that answers the first question right there. Now, when does it not exist? Well, it doesn't exist when the denominator is equal to 0. So when is the denominator equal to 0? Well, whenever this part right here is equal to 0. So I could take x squared minus 1, set that equal to 0, x squared equals 1, and x equals plus or minus 1. So it does not exist when x is plus or minus 1, and it's 0 when x is 0. Okay, let's move along. All right, differentiating a quotient. You could use the quotient rule on this. I would probably avoid that. I'd rewrite this thing as negative 7 times 2t minus 3 to the negative 2 power. Now I can differentiate this really easily. Negative 2 times 7, times negative 7 is 14. 2t minus 3 to the negative 3 power. Make sure you get that right. A lot of people put a negative 1 there, and that's wrong. Okay, and then I got to take the derivative of this. So the derivative of the inside is 2. So then g prime of t is going to be 2 times 14 is 28. 2t minus 3 to the negative 3. You could leave it like that. You could rewrite it like this if you liked. G prime of t is going to be 28 over 2t minus 3 cubed. Either one of those is going to be fine. Okay. Next, example 7, simplifying by factoring out the least powers. Okay, so the first thing that I would do with this thing is rewrite this. f of x is x squared times 1 minus x squared to the 1/2. Okay, so the next thing that you'd want to do is you'd want to use the product rule on this thing. So f prime of x is going to be this times the derivative of this. So 1/2 1 minus x squared to the negative 1/2. Then remember, to use the chain rule, I got to multiply this by the derivative of the inside, which is going to be negative 2x, plus the derivative of this, which is 2x, times this, 1 minus x squared to the 1/2. I got some cleanup to do on this thing. So f prime of x, this is going to be, the negative 2 is going to cancel with the 1/2 here. And I'm going to get negative x cubed over the square root of 1 minus x squared. The negative power puts it in the denominator, and the 1/2 power means that it's the square root, plus this is going to be 2x times the square root of 1 minus x squared. Okay, now I would like to get a common denominator and combine this to clean it up a little bit. So I could take this right here and multiply this by the square root of 1 minus x squared over the square root of 1 minus x squared. Now that has a value of 1, so it does not change the value of this. Okay, so f prime of x is going to be negative x cubed over the square root of 1 minus x squared, plus 2x times 1 minus x squared, because this times this is 1 minus x squared, all over the square root of 1 minus x squared. And now I have common denominators, so I can combine my like terms. And I'm going to get negative x cubed. Over here, I'm going to get plus 2x minus 2x cubed all over square root of 1 minus x squared. And then I can simplify that a little bit. F prime of x is going to be negative 3x cubed plus 2x all over the square root of 1 minus x squared. Now I did all that algebra. I need to go back and make sure that I answered the question that they wanted me to answer. So it just said find the derivative. There's the derivative. I'm done. Okay, simplify the derivative of a quotient f of x equals x over the cube root of x squared plus 4. Find the derivative of f of x and simplify it. Okay, so I would rewrite this equation as x over x squared plus 4 to the 1/3 power. Okay, and now you can go ahead and use the quotient rule. So that's going to be f prime of x. It's going to be g of x, so that's this, x squared plus 4 to the 1/3, times the derivative of f of x, that's just going to be 1, minus f of x, which is x, times the derivative of this, which is going to be 1/3 x squared plus 4 to the negative 2/3 times the derivative of the inside of the function, which is going to be 2x. All of that will be over g of x, in this case, the denominator here, squared. So that's going to be x squared plus 4. Instead of the 1/3 power, it's going to be the 2/3 power. Okay, let's clean this up a bit. All right, this is x squared plus 4, and I want the cube root of that, minus 1/3 times 2 is 2/3 x squared times let's write this a little differently. 2/3. I got x squared in the numerator, and I've got a cube root of x squared plus 4 squared in the denominator. And then I've got another denominator, and this is the cube root of x squared plus 4 squared, like that. Okay, so we got some algebra to simplify this thing. I would go ahead and multiply this one over here by 3 times the cube root of x squared plus 4 squared over itself. Let's see if we can thin those lines out a little bit and make it a little clearer to read. There we go. Okay, what do I get when I do this? F prime of x is now no, I don't think I want to do that. Okay, so there's some rather hard algebra with this, so I'd take a pause there for just a second and figure out my algebra here. So we're going to go back. We're going to get rid of all this. Okay, let's try again. So here's where the difficult algebra comes from, is that we're just going to look at the top of this. Okay? We're going to factor out of this 1/3. Okay? Now, and we're also going to factor out this x squared plus 4 to the negative 2/3 power. Now, if we do that, what does that leave? All right, here's the really tricky part. If I factor out a 1/3 here, I need a 3. Okay, now why is that? Because if I distribute this back in here, 1/3 times 3 is going to be 1. Okay. Now, if I also factor out this x squared plus 4 to the negative 2/3, here I have x squared plus 4 to the 1/3. That's going to leave me with an x squared plus 4 to the first power. Okay, so if I'm dividing out a negative, I'm really subtracting a negative or adding a positive to the power there. Now, if you can wrap your head around that part of it, the rest of this is pretty easy. Because over here, When I factor out the 1/3, this just goes away, and I factor out this, it just goes away. It leaves me with x times 2x, which is 2x squared over here. And then the bottom of this thing is just the bottom, x squared plus 4 to the 2/3 power. Okay. Now what happens? Well, I got a little bit of tough algebra here again. F prime of x. Okay, I got a negative power in the numerator. I don't like that. I'm going to move this to the denominator. That means that my denominator is now going to be x squared plus 4 to the 4/3 power. I'm going to add those exponents, 2/3 and 2/3. Also, I'm going to have a 3 down here. Up here, I have 3x squared plus 12 minus 2x squared. I can go ahead and combine my like terms. 3x squared minus 2x squared is just x squared plus 12 over 3 times x squared plus 4 to the 2/3 power. You could rewrite that if you really wanted to be x plus 12 over 3 times the cube root of x squared plus 4 squared. That's the same thing. Okay, that is a tough problem with very difficult algebra. Okay, simplifying the derivative of power. So, find y prime and then simplify it. Okay, can I rewrite this? Not that I can see. So y prime is going to be 2 times this stuff times the derivative of the inside. This is where this is going to get tricky. So it's going to be a quotient rule. So we take g prime, or I'm sorry, g of x times the derivative of that minus f of x times the derivative of this all over that squared. Okay. Now I got a lot of simplification to do. So let's start with this stuff over here. It doesn't look like the algebra is too difficult over here. We'll just do this a step at a time. I could take this 2 and multiply it in here, so that'd be 6x minus 2 over x squared plus 3. Over here, I'm going to get 3x squared plus 9 minus all of this stuff. So this is going to be 6x squared minus 2x all over x squared plus 3 squared. Okay, now I can combine my like terms. Looks like at least the algebra is a little bit easier on this one. Although apparently the writing isn't. So this is going to be 6x minus 2 over x squared plus 3. 3x squared minus 6x is going to be negative 3x squared. I got an x term here, so it's going to be minus a negative, so plus 2x plus 9 over x squared plus 3 squared. Let's see. Fortunately, I'm multiplying fractions, so I multiply the numerators and the denominators. The denominator is easy. That's just going to be x squared plus 3 to the 3rd power. If you, I know you guys like to box stuff up, so you can take this over here. And you could multiply this out. So this would be negative 18x cubed plus 12x plus 54x. This would be minus 18. This would be minus 4x. And this would be 6x squared. So if I multiply out the numerators of this thing, this should be, this should be 12x squared right here. This should be minus 18x cubed plus 18x squared plus 50x minus 18. And you're done. All right. So some trig functions in the chain rule. So the derivative sine of u is cosine u times u prime, okay, or the derivative of u. This would be like if you had a 2x in here, then it would be cosine of 2x times the derivative of 2x, which is 2. Same thing over here, derivative of cosine is going to be negative sine u times the derivative of u. Derivative of tangent u is going to be secant squared u times the derivative of u. Cotangent u is going to be negative cosecant squared u times the derivative of u. You've seen all these formulas before. It's just that you're adding a composite function, so you have to use the chain rule and take the derivative of whatever's inside the function. Otherwise, it's exactly the same. So let's look at this one. Find the derivative of y equals sine of 2x. Y prime then is going to be the derivative of sine is cosine of 2x times 2, because the derivative of 2x is 2. The derivative of cosine of x minus 1, derivative of cosine is negative sine of x minus 1 times the derivative of what's on the inside. That's just 1, so I don't really have to do anything with that. I'm done. Y equals tangent of 3x. Okay, so y prime, derivative of tangent is secant squared of 3x times the derivative of 3x, which is 3. So those were all pretty simple. Okay, a little bit different because I got things in parentheses here. So they all, these first three are very similar, but depending on where the parentheses are, it changes the problem. So if we look at cosine of 3x squared, and we take the derivative of cosine is negative sine of 3x squared times the derivative of the inside, which is 6x. So this would be negative 6x sine 3x squared. Okay, now look at where the parentheses are here. This is just cosine of 3. That's just a constant. Okay, so the derivative of this is just a constant like 2. All right, so it's going to be 2 times that constant, drop the power 1. Done. Nothing else to do to that. Okay. This one here, cosine of 3x quantity squared. Okay, so y prime. Now, the square goes with just the 3x here. So the derivative of cosine is negative sine of 3x squared Now I got to take the derivative of the 3x squared. That's going to be 6x. So this is going to be negative 6x sine 3x. Oh, wait. It's the whole thing squared. Sorry about that. Need a bigger eraser. There we go. Okay, so I would go ahead and rewrite this. 3x squared is going to be cosine of 9x squared, like that. Okay, now take the derivative. Y prime is going to be negative sine of 9x squared times the derivative of the inside, which is going to be 18x. So this is going to be negative 18x sine 9x squared. Remember, you're squaring everything in the parentheses here. Okay, this here. I would rewrite this one as cosine x squared. Now when I take the derivative, it's 2 cosine x times the derivative of the inside, which is negative sine x. And you're done. Okay, I would rewrite this one as cosine x to the 1/2 power. Then y prime is 1/2 cosine x to the negative 1/2 times the derivative of cosine is negative sine. And then you could rewrite this as negative sine is going to be the numerator, and I'm going to have the square root of cosine and a 2 down here for the 1/2. Okay, repeated application of the chain rule. All right, so I've got sine cubed of 4t, find the derivative. All right, so I'm going to rewrite this. F of t is going to be sine of 4t to the 3rd power. So then f prime of t, 3 times 1 is 3 sine of 4t times the derivative of the inside. Well, the derivative of sine of 4t is going to be cosine of 4t times the derivative of what's inside there is going to be 4. So I can take this 4, clear out here in front with the 3. That's going to be 12 sine 4t cosine 4t. So I had to use the chain rule multiple times because I had a function inside a function inside another function. Okay, so again, I take the derivative of the outside, 3 sine 4t. I take the derivative of the inside, which is derivative of sine 4t is cosine 4t. I take the derivative of the inside of the sine, that's going to be 4. Find an equation of a tangent line to the graph if f of x is 2 sine x plus cosine 2x at the point pi 1. Then determine all values of x on the interval 0 to 2 pi, at which the graph of f has a horizontal tangent. Okay, so here's my graph. Okay, here's my interval 0 to 2 pi. So I'm going from here to here. Okay. And find the equation of the tangent line. Okay, so if I'm going to find the equation of a tangent line, I need to find the slope of that line. So I'm going to find the derivative of f of x. So the derivative of f of x, f prime of x, is going to be, derivative of sine is cosine, so this is going to be 2 cosine x. Derivative of cosine is negative sine 2x. Use the chain rule, I get a 2. Derivative of 2x is 2. Okay, I want to know what the slope is at pi, so now I'm going to plug in f prime of pi. So this is 2 cosine of pi minus 2 sine of 2 pi. Well, let's see, sine of 2 pi, that's 0, so this is all 0 over here. Cosine of pi, let's see, cosine of pi, I always forget, but I can make a graph. Cosine looks like this. So it's negative 1. So this is negative 2. So the slope is negative 2. Okay, and I would, let's see, find an equation of the line. Okay, so I know the slope. I don't know the equation of the line yet, but I do know that y equals mx plus b. I do know the slope is negative 2. I do have an x coordinate. The x coordinate is pi. And I do know the y coordinate, that's 1, so I just got to figure out what b is. So b is 1 plus 2 pi. So my equation of my line then is going to be y equals negative 2x plus 2 pi plus 1. So I've checked off the first thing. Determine all values of x on the interval 0 to 2 pi at which the graph of f has a horizontal tangent. Okay, so if it has a horizontal tangent, looks like there's 3 points here, because that's where the tangent is going to be a horizontal line. It's going to have a slope of 0. So what I can do is I can take the derivative and I can find when the derivative 2 cosine x minus 2 sine 2x is 0. Okay, when is that going to occur? That's going to occur when 2 cosine x is equal to 2 sine 2x. Just move this over to this side over here. Okay. Had to work out a little bit of, go get my trig chart and refresh my memory on some of the trig here. So, where were we? I can divide this 2 out of this on both sides, and I need to know when the cosine of x equals the sine of 2x. Okay, so there's a way you can get a couple of these by algebra. If you remember, the sine of 2x is 2 sine x cosine x, and that equals cosine x here, and I can divide both sides by cosine x, and I get 1 equals 2 sine x, so then 1/2 is sine x, and then I can arc sine that, and I get x is going to be pi over 6, 5 pi over 6. So that gives me 2 of the answers right here. That one and that one. So this is pi over 6, and this is 5 pi over 6. Now, the trickier thing is to figure out the other two. And if you had a trig chart, it's pretty easy, because if you look at the cosine of pi over 2 is equal to the sine of pi, which is twice as big as pi over 2. Okay, both of those are 0. So that gives you this one right here. And then this one appears to be at 3 pi over 2. So if you look at that one, the cosine of 3 pi over 2 would be equal to the sine of 3 pi. And sine is always 0 in all the whole pi's. And so that's 0 here. So there's 4 times where you get the answer. 3 pi over 2. So there's your 4 solutions. Okay, here's your assignment. Go ahead and take a look at some of those problems, and I'll catch up with you next time.